So today I'm just working on the 315BL Caterpillar excavator. It's a 15 metric ton cat excavator. Kind of an old machine now. I'm approaching 25 years old, I would guess. But I'm going to demonstrate the use of valves to configure attachment plumbing into single acting or double acting. So single acting for something like a hammer or breaker, double acting for something like a ditching bucket, or where you need two-way flow. And I also want to talk about one pump flow and two pump flow. So the reason I'm working on this older machine for educational purposes is because this machine is configured for different attachments using good old-fashioned standard ball valves. So these are all hand-operated ball valves. And there's basically five valves on this particular machine that can be configured to an open position or a closed position to give us different arrangements for different plumbing. So that's the attachment package that this machine came with. More modern machines, more sophisticated machines may use some sort of tool control, programming through the monitor panel, and instead of mechanically operated valves with handles on them like these, you may have solenoid operated valves on the machine that are going to do the configuration, and they might be buried somewhere where they're difficult to find. These ones are out in the open because the expectation is that the operator or mechanic can position these valves. So I just want to talk about the function of these valves. If you're working on a newer machine, whether it's Caterpillar or not, the control of one pump or two pump flow and single acting or double acting is going to be basically the same, but it may not be so obvious how the plumbing is actually affecting that. So I like to use this old machine with ball valves so you can literally see between these valves and the schematic, you can literally see how the valves opening and closing are going to change the type of flow you get to your attachment lines. So we basically have five ball valves, as I mentioned. This one next to the cab on this machine, it's going to be in different locations on different machines, but when that valve is open, what that's going to do for us is give us pilot supply from the attachment function pedal in this machine to operate two spools. So in the main directional control valve back in there are two attachment spools, and Caterpillar calls them attachment 1 and attachment 2. And there's two main hydraulic pumps on this machine. One, they're in that pump compartment over there. One of the pumps feeds one half of the control valve. The other pump feeds the other half of the control valve. And so there's an attachment spool in either side. And if you use both spools together, then the flows can combine to give you what's sometimes called combined flow, and then you get two pump flow feeding your attachment. So each pump on this machine is capable of putting about, I believe, about 30 gallons per minute. I don't have the specs in front of me. So if you've got the system configured for two pump flow, you can have pretty close to 60 gallons per minute feeding your attachment at low pressure. And if you close that valve and go to one pump flow, then you're going to be limited to about 30, low 30s as far as flow rate goes. It doesn't literally double on this machine, and doesn't on many excavators, but we'll talk about the whys and wherefores of that later. So that, on this particular machine, that valve is going to enable the pilot system to operate both the attachment 1 and attachment 2 spools in the main directional control valve. So that's part of the picture to get one or two pump flow. There's another valve on this machine right down in the pump compartment that we'll go look at here. I'll just show you the two pumps. This machine's got Kawasaki pumps, like a lot of excavators in this size class. There's a pump, the front pump, what they call the front pump is the one closest to the flywheel of the engine. This is the rear pump. The front pump feeds the side of the control valve that has attachment 1 in it. The rear pump, this pump, feeds the side of the control valve that has attachment 2. And the way it does that, it actually tees off the supply here, comes down this line, and right here in the floor of the pump compartment is a ball valve. So if that's closed, doesn't matter if you opened the pilot valve we were just looking at next to the cab window there. If this is closed, you're not going to have 2 pump flow. So in order to get 2 pump flow to your attachments on this machine, 2 valves need to be open. One that actually adds the physical 30 gallons per minute or so approximately on this machine through this hose. And then we also need to open the pilot valve that's going to allow pilot pressure to actually physically actuate the attachment to spool. So 2 things are required to get 2 pump flow on this machine. The pilot 2 pump flow valve has to be open, and the pump supply 2 pump flow valve has to be open. So with both of those open now, I should be able to get just about almost 60 gallons per minute, I believe, up at the attachment line. So just gonna make sure this one is open. So this one's open. The one by the cab window is open. We'll just check. We've got our flow meter hooked up here. So this will read our flow in gallons per minute. Over here we're reading pressure. I'm just recycling these so they don't time out on us. Not that we're that concerned about pressure for this demonstration. But now when I operate the controls, this particular excavator is using a pedal for the auxiliaries. So we'll just start this guy up. Take it to high idle here. Get about 56 gallons per minute through our flow meter. Pressure, almost 900 psi. I've got that load valve wound wide open, but as the oil returns, it has to go up the return line. It's got to go up the return line. It's got to go through all the lines and fittings, back across the valve, then it's got to go through the oil cooler, through the oil filter. So even with no attachment plumbed up, we saw about 900 psi almost of just sort of back pressure in the system. Of course, the oil's not up to operating temperature. That might go down a little bit as the oil warms up and thins out. It is a warm day here, but I haven't been running the machine much, so it's not very warm. So we have 2 pump flow. So let's go look at how we put that into single pump flow. 2 pump flow is great if you've got a large flow requiring attachment, like a breaker. But some attachments, that may just be way too much oil, and things might happen way too fast, and the operator may struggle to control them. So by turning that valve closed, I put this machine into 1 pump flow. Whether or not I go into the pump compartment and shut off that other valve is not really going to be any consequence, because this hose is feeding a directional control valve that's not going to shift anymore anyways, because I'm not sending pilot pressure there. But just for process, I'll close this one too. That will ensure that we do not get 2 pump flows. We'll just see again how much flow we get with only 1 pump feeding our auxiliary circuit. Just start it up again. As I mentioned, it's not going to be exactly half. We're getting about 37 gallons per minute with 1 pump, and that seems to be the MO of these cat excavators. The attachment 1 spool tends to give us a little more flow than the attachment 2. 450-ish psi now. That sort of stands to reason. Less flow through the return path, so we got less back pressure, and that may be part of why the second pump isn't quite adding an equivalent amount of oil as the first pump, because as we increase the back pressure, the pumps are going to leak more internally. At 900 psi, I don't think we're reaching the point where we're going to be de-stroking the pump, but that might depend on what power mode you're in on the electronics as well. So now we're in one pump flow. Now I want to talk about single acting, double acting. So I've got a foot pedal. That's not typical. A lot of these cat excavators, if you had a third pedal in the cab, that was for third pedal straight travel. Well, in this machine, this is actually our auxiliary attachment control. So what I'm going to do is try the heel and toe and watch the flow meter, and we'll see how that affects the flow through the attachment lines. So even just at idle, if I touch the toe, I can see flow on my flow meter, about 15 gallons a minute almost at low idle. I'll take that up to high idle. Yeah, we're about 37 gallons a minute. If I use, so that's pushing with the toe. If I push with the heel, 0. At 0 flow at high idle or low idle with the heel. That's because I am in single action setting on some other ball valves we need to look at. So we looked at the two ball valves that are involved with single and double acting, or single and double acting flow. We looked at one pump, two pump flow. Now we need to look at single acting or double acting. Right now our machine is configured for single acting, where the toe sends oil through the flow meter, through the attachment lines. Heel does nothing. If I want to have heel and toe operation for a double acting attachment, like a ditching bucket or a clamshell bucket or a grapple or something that needs direction, oil and flow in both directions, then I need to go look at some other ball valves. One in particular. Let's go. So out here in the other side of the center area of the machine, just back out for perspective. Looking down in the center section, there's the cab. Over here on this side, there's another ball valve dealing with pilot lines, and when this one's open, this will allow pilot flow from the heel side of the pedal in the cab to go to the bottom of the attachment valves to operate them. So I've opened that now. I've got the handle in line with the oil flow through it. So now we should have double action. We should be able to use heel and toe to control bidirectional flow through the attachment lines. So we'll just test that theory. And on our flow meter, so with the toe, again just a low idle, so I'm only seeing about 14.5 gallons per minute. So that was toe. I'll try the heel. I push the heel. I've got 15 gallons per minute. So I've got, that's heel, that's toe. Why they aren't exactly the same? I would say our attachment spool is not moving fully in one direction, and it's moving a little more further in the other direction. That could be fixed by shimming the centering spring if you needed perfectly matched speeds. So now I've got the machine configured for bi-directional two pump flow. I'm going to be dealing with high idle. Oh, sorry, I put it into single pump flow. So now I got single pump flow. About 37 gallons a minute. That's with the toe. with the heel, about 38 gallons per minute. So I've now got the machine configured for a smaller double acting attachment. So if we put the ditching bucket on this machine, that's the way we set the valves. We set them for single pump double acting flow. So one pump flow, double acting. That's the way I've got the machine set up right now. So just by configuring some ball valves, I can set the machine to single acting or double acting. Now what I'm going to do, while I'm looking at that pressure on the pressure gauge, I'm just going to turn the key on because the pilot supply is solenoid acting. I'm just kicking the heel and toe to get the pressure off of the attachment lines in case I want to uncouple the quick connectors. Now, we've looked at 3 different valves so far. We've looked at a pilot valve just outside the cab here for 1 pump, 2 pump flow. We've looked at the pilot valve on the far side of the cab there for single acting, double acting, and because it's open right now, we're in double acting. There's 2 more ball valves. There's a one back there on the return line, and there's another one here on the back side of the boom. So let's go look at those and talk about what they do. So if I was going to put this machine into single acting for something like a hydraulic hammer that may have some issues with back pressure, this handle allows me to open a valve, and the handle's kind of on counterintuitively. If you feel the cross on the top of the valve, that position is the handle is actually open on the valve. You can take this cover off to see it better if needed. And you'll notice that the line coming back, the return side for single acting, comes to a block here and turns and goes down and returns through the attachment spool of the control valve. And when it does that, when you send the return oil back that way, it goes across the valve, across the through the DCV, through the oil cooler, and back through the return filter. If you need to get rid of back pressure, you can open this return valve, and then your return flow will bypass the DCV and go back right into, I believe, into the filter housing on this machine. So it'll be bypassing the oil cooler and bypassing the directional control valve, and thusly getting rid of a whole bunch of back pressure. So if you've got a hydraulic hammer or some other attachment that is sensitive, runs in single acting flow, but is sensitive to back pressure and won't function properly with too much back pressure, then you can open that valve. Because remember, we saw almost 900 psi back pressure. So I'm going to put this back into single acting and 2 pump flow, and we'll just see what kind of difference that makes to our back pressure having that valve open. I think I opened it. It's a little bit tricky to tell which way the handles are mounted on that, so I'm going from memory, but we'll see. So again, I'm going to put it back in 2 pump flow. I've added the 2nd pump flow here, and I'm just curious to see when we have full 2 pump flow at high idle, how much back pressure we have in the return side of the circuit. So again, I'm in single acting, and I'm in 2 pump flow at high idle. Get a little more flow, get almost 60. And the back pressure, it hasn't been reduced much. It's brought us down about 100 psi. So by bypassing the hydraulic oil cooler and the directional control valve, We haven't got. That's a little bit. That was a little bit disappointing. I thought we'd get rid of a little more back pressure than that, but we got rid of about 100 psi. Went from the 900 down to 800. But that might be the difference between functioning and not functioning for something like a hydraulic hammer. There are other ways to get rid of more back pressure if required. We could bypass the filter and return right to the tank. However, some cautionary messaging in that. I don't think I'd want to bypass a filter for most attachments. Something else can be done, even if you don't have that valve. We could take the anti-cav and port relief out of the return side of the DCV and take the guts out of that relief valve and put the housing of the relief valve back in to create a big opening between the work port and drain. And then we'd want flow both directions back to tank, so we might have to gut that ball valve too. Well, no, actually, you could just leave the ball valve open. That would provide a parallel return path for some of the oil, and that may help in reducing return restriction. So that's the function of that fourth ball valve. Now there's a fifth ball valve that we haven't looked at in any detail, and that's the one on the back side. Boom. Also to do with mainly with single acting attachments. So this is the supply line here for the auxiliaries. That's the attachment line going up and feeding. So in single acting, we're feeding to the left side of the quick connectors on this machine, and then teeing off of that pipe on the supply side for single acting. This hose runs to this ball valve, which is currently closed. See the line this way, indicating the oil flow is blocked. And if I open that, now I've opened that flow to have access to a relief valve. So this is a relief valve that can be put into the system by opening this ball valve. It can be isolated from the system by closing that ball valve. So this relief valve can be set up specific to certain attachments that run on single pump flow. If you want to limit the pressure in that line, you can set this relief valve accordingly. So that would typically be used for something like a hydraulic breaker or a hammer, where the pressure spec isn't sufficient for full system pressure of the machine. If you don't want the main relief on this machine limiting your pressure, you want to lower it to something less, this relief valve can be cranked down to the setting, and then you can limit your maximum pressure for a single acting function. It won't work. This isn't a bidirectional relief valve. It won't limit the pressure in this line, but you can see this hose coming off of that relief valve. Once the relief valve opens, the oil blows out this line and just connects into the return pipe. So this would be a single acting relief valve for particular attachments. So we've got 5 ball valves in total for configuring attachments on this machine, and that's just a quick overview of how they all function. I may do a second video where we consult the schematic and we look schematically at how these are arranged on an ISO schematic of the machine. But that's a quick overview of how the machine can be configured for single acting attachments, double acting attachments, 2 pump flow, or 1 pump flow. Not all excavators are going to have that flexibility. Some may be ordered just with a single acting hammer lines group, it might be called, from marketing perspective. But this is what Caterpillar in this era called common piping, and you could configure it to run a variety of different attachments. And of course, you've got to get out of the cab and actually configure some ball valves. But I actually like this setup because it's easy to see what's happening and explain it. Again, if those are all solenoid valves and you're going in through tool control, that might seem better from a setup perspective, but I like having access to these valves. and they don't often put them in a friendly spot if they're using solenoid valves. Hope that helps.